Hello, good afternoon, students. I hope you can able to see me clearly, guys. Good afternoon to each and every one of you guys. Please ask your friends to join the class. Good afternoon, Jagan. Good afternoon, Siva. How are you guys? How? Just a minute. I'll just. Okay, yeah, it's fine. Okay. So I hope everything is fine, right, at your end, and I hope you guys are trying to solve questions from module. So how was the last class, guys? How did you find it out? Good afternoon, Sarava. Good afternoon, Aswini. Good afternoon to every one of you students. So I'm just launching technical poll. Please let me know. Am I clearly audible and is the screen is visible to each and every one of you? Just let me know, guys. So today will be a very interesting class, guys. Today's class we will be trying to deeply understand the concepts and we'll be trying to solve few questions also. Okay, not only concepts, we'll be also trying to solve few questions as well as we'll be understanding the magnetism and matter thing. Okay. Okay, guys. So I hope every one of you have informed your friends to join the class, guys. Please inform your friends. We're gonna start the class almost at 3 o'clock, 3:01. Okay, after one we'll wait 1 minute. Till then, please inform your friends to join the class and answer the poll. Am I clearly audible? And is the screen is visible to each and every one of you guys? Very good, very good. I can see most of you are replying that I am very clearly audible and screen is also visible. That is really nice. Please inform your friends to join the class, guys. Good. Hello, Hema. Guys, tomorrow you will be having test. Okay, make sure that you feel comfortable with respect to the test. Tomorrow you guys will be having test with respect to the chapter magnetic effect of electric current. That is the previous chapter. Is it clear to each and every one of you? Please inform your friends to join the class, guys. Very good. Join fast, right? Okay, good. Good afternoon. Good afternoon to each and every of you. Those who are joining the class. Good afternoon, guys. Inform your friends to join the class, students. Then we're gonna start the class almost in another 1 minute. Okay. Till then, you can fill the response whether am I clearly audible and is the screen is visible to you, students? Okay. Good. Good afternoon, Priya. Yesterday, sir, network. So yeah, at my end, actually, it is raining from past 4 days. So no idea. So it was like there was no power for morning. There were lots of network problem yesterday. Okay, so I can see that most of you are saying that I am clearly audible and screen is also visible. Good afternoon, Dhanush. Good afternoon, Priya. Good afternoon to all of you students. Good afternoon. Yeah, yesterday there was network problem. Okay, guys. So we're gonna start the class, guys. Yeah. So almost 3 o'clock. We'll wait for another 1 minute to join your friends. Okay. So before starting the class, let me tell you that how the class will be going on, right? Sir, previous chapter notes here, sir. Previous chapter notes are there in the description, Sachin. You can check on the description, Sachin. It has already been shared with you. Using two methods, we used to share the previous chapter notes, guys. Either first method is we directly share you on the WhatsApp group, whichever day we teach you. Second method is we also share in the WhatsApp group description. There is something called notes. I think so link everyone is having. So in that I have uploaded in both the manners. In one manner where all the notes are there. Second manner I have uploaded it day by day, so that you can be very confident in revising the notes. Okay, because I can see very less students are revising the notes. Okay, so make sure that guys you do have the notes, and if you don't still not getting the notes, Sachin, please talk with me in WhatsApp after the class. Okay, because it is very mandatory that you guys need to have access with the notes, guys, because notes are the thing that is going to help you for long term. Okay, guys. Yeah, so I can see only 50 students have joined the class. Please inform all of your friends to join the class, guys, so that we can start the class very efficiently, students. Okay, good to see. Okay, guys, it's almost 3 o'clock, plus minus 1 minute, right? So we can start, right? Okay, let's start the class without wasting lots of time. I hope everyone is good at their end, and good afternoon to each and every one of you guys. Yeah, no, it's fine. So as we were learning about this chapter, this is the third day of this chapter, right? This is the third day we are learning this chapter, right, students? The third day. So as we are learning third class, basically, as we were learning about this chapter, magnetism and matter, we got an idea about that. How can I visualize Earth? Tell me how to visualize Earth, guys. Tell me how to visualize Earth. So as you know, to visualize Earth, we have took Earth as a bar magnet. We have took Earth as a bar magnet, right? So yesterday someone with sir have taught you lots of things regarding the earth magnetism. Today also I'll be teaching you these all things. I'll be not going too much ahead, guys, because tomorrow you guys are having test, so I don't want you to give lots of burden, right? So I will teach you those all things, conceptual understanding that makes you feel good or happy also regarding that. Okay, you have learned things regarding this chapter. Why this chapter is important? This chapter is very important regarding the concept of magnetic field with respect to earth, guys. Earth. Okay, and NEET, from NEET and JW, they directly ask questions from this chapter. So please, those students who are leaving this chapter, or those your friends who are leaving this chapter, ask them not to leave this chapter, because this is one of the easiest chapter. Only conceptual understanding you should have, you can easily solve the question. Okay, some questions are bit tricky, but most of the questions are very easy to solve, guys. Okay, so let us proceed. I can see very less attendance, guys. Only 60 students. Why? Where are other guys? Inform your friends to join the class. What is this? Okay, let's move ahead. So basically, how our today's class will be going on, we'll be doing basic revision, whatever we have learned in past two class. Okay, then we're gonna understand about earth magnetism in detail. Okay, and then we're gonna understand about angle of dip and angle of inclination. Don't worry, guys, I'm not gonna make you explain angle of deeper inclination based on the factor of drawings. Okay, I'm gonna explain you based on the factors of how it looks in 3D, what exactly is going to happen, how NASA have thought about this, and what all things are there in your NCRT books. Okay, because this chapter is totally based on understanding. And then if you have time, we're going to move ahead with questions. Okay, so I think so you can easily solve the questions from your module. Last to last class, I have shared the module with you. The module name is P19, guys. Make sure that you start solving the questions from module, not today, might be after the exam tomorrow. Okay. Okay, students. So if you're comfortable, let us proceed. Good afternoon to each and every one of you. Utilize students. Gopika, good afternoon. Good afternoon, guys. Okay, good. Yeah, very good, Soumya. So let us start with the basic revision. When we speak about basic revision, as we have learned in our basic revision term, that is in our last class, if you guys can remember, we have understand about the earth magnetism with respect to the bar magnetics. So what all things we have done revision with respect to the basic things is nothing but we have talked about 5 different factors, guys. Can you guys remember? So we have talked about 5 different factors. If you guys can remember, it will be very good. Please try to go back in your notes and tell me what are the 5 factors. So we are writing the factors with respect to that is analogy, right? Electric field, we are trying to correlate electric field and magnetic field. So these are the two analogy that we try to correlate, right? So the first analogy, yeah, very good, Hema, very good. So the first analogy that we have tried to understand is with respect to the electric field only, right? Electric field only. So I'm not going to go too much detail, but I'm going to make you understand that electric field is represented by E, which is given by nothing but you have learned in electrostatics KQ by, I'm really sorry. Yeah. So you can easily write KQ by R square. Right. Similarly, the second analogy that we try to understand is with respect to nothing but dipole, students. Right, guys? We have something called dipole. So over here also we have nothing called magnetic field, which is represented by B. We have learned lots of formula in our last class with respect last chapter, guys, Biot-Savart law, right, students? Then we have got to know about dipole. So over here also we have nothing called dipole. Very good, Srava. So we have called magnetic dipole, guys. Right? In dipole, we have 3 cases, students, if you can remember. So what are all the 3 cases? Under the dipole, we have 3 different kinds of cases. Dipole can be there in the 3 different. Very good. The first case can be axial. The second case can be, guys, I'm not telling you, please keep this in mind. I'm not telling you to remember all the formula. I'm telling you to have an idea that there is something like this is available in the book. And if you have some kind of idea like that, I'm pakka that you will be feeling comfortable. Okay, we have something called axial, right? We have something called equatorial. You should know the meaning, guys. Equatorial, right? And third, the major important factor that we have is nothing but random, right? So based on these 3, we have 3 different kinds of formula. As you know, the formulas go with respect to. So I'm not writing down the formulas. So I hope you can remember 2 kp by r cube, kp by r cube. So axial formula is nothing but 2 times of kp by r cube, right? Equatorial formula is nothing but minus kp by r cube, right, students? And the random formula is nothing but kp by r cube root under 1 plus 3 cos square theta, right? So these are all the few basic formulas that you need to remember. So these are the formula on the left hand side. Whatever formulas we are having are the formulas with respect to electrostatics chapter. Okay, students. Yeah, cos theta. Is it cos theta? Yeah, I think so, cos theta. Okay, so left hand side is based on the electrostatic chapter, but right hand side are based on the, so in magnetic also we have something called three things are based on the magnetic field chapter. That's why I'm trying to give you analog. The third important factor that we got to know is about torque. We understand that over here also we have nothing called torque, which is given by nothing but R cross P, right? Over here, what we, so P cross E, right? So we used to write tau is nothing but P cross E. But over here, we used to write tau is nothing but, tell me guys, M cross B, guys. Very important to remember that it is a cross product. Okay, students, it is a cross product. What if I write dot product, guys? Can anyone tell me what if I write dot product? What it will become? Tell me, students. Very mandatory equation. What if I write dot product? Don't tell me cos and sin theta, guys. I don't want with cross product. I assume that you know these all things, guys. Cross product means it is very assumed that you know that it is nothing but MB sin theta, and dot product is nothing but MB cos theta. But what is dot product? Very good, Sachin. Very good. So you should remember that when you try to do cross product, you're gonna get nothing but torque. But when you're gonna do dot product, students, you're gonna get work. You're gonna get work. So when I speak about work can have different names, students. That is known as potential energy. You can write work as potential energy also. Work you can write as energy also. So make sure that you know these all things, guys. You know these all terminology. So if in the question they ask that what is the potential energy due to a magnetic field, it should strike in your mind that, oh my God, potential energy is nothing but M dot B. That means MB cos theta, right? Very good. Yeah, the sign will be minus. I'm really sorry that you're gonna keep the sign. Why it is minus? Can you tell me? Just because it is gonna decrease, right? It is gonna come from higher to lower. Okay. So if these things are clear to each and every one of you guys, then we can. So over here also energy is written by U is equal to P dot E, guys. That is a very beauty things, right? So this is a comfortable thing to remember. Yet we have not tried to solve questions based on these things, but today we're gonna try to solve. Okay, so let us move ahead, guys. So one more basic thing I've tried to make you understand is with respect to the magnets. So I told you that suppose this is my earth, students. So I can treat my earth as a magnet, right, guys? So I can treat my earth as a, suppose this is my south pole, this is my north pole. So I can treat my earth as a magnet. So how the magnetic, why I'm treating my earth as a magnet? Can anyone tell me the reason? What is the reason? क्यों बोल रहे? Why I am speaking that my earth is acting like a bar magnet? Why? What is the reason, guys? As you know, the property of bar magnet, the bar magnet look like this, right? We have something called north pole, south pole, and from north pole to south pole, the magnetic field line passes, right, guys? So tell me, students, why is it so? Yeah, that is correct answer, Amit. Work is m dot b, negative of m dot b. So that's why I put a negative sign. Don't worry, Amit. Okay, due to poles, not due to poles. Never is a no. Those are the uneven reason. Actually, what is happening? Think about it. So, guys, this is still a topic. So, can you show the field lines in horseshoe magnets? Horseshoe magnets, see, it will go like this. So, horseshoe magnet goes like this, right? I know you will be very interesting to see. So, if you have north pole and south pole, so tell me how the magnetic field lines should go. Tell me how the magnetic field lines should go. So, magnetic field lines should go from north to south pole. So, they go like directly like this. Is this understandable? Is this understandable, Anjal? I hope it is clear because horseshoe magnet is somewhat looking like a U shape. Don't worry, they're not going to ask too much deeper right now. The magnetic poles will be M over here and the magnetic pole strength will be M over here, right? Earth also have a magnetic field, but why? Why? Good, right? But why Earth has a magnetic field, guys? This topic is still under consideration of, I can say, you can, if you're gonna find, suppose that why Earth is having magnetic field, you can get Nobel Prize, guys, because yet none of the scientists have till now find it out that what is the reason of having Earth as a magnetic field. Okay, even we cannot see the magnetic field till now, right? We just have visualized that there is some kind of line passing from there. Right, students? So let me tell you an interesting fact what scientists have told us about that why Earth is producing a magnetic field. Actually, everyone knows, guys, inside my Earth, what is there inside my Earth? I have something over here there, guys. What is this, guys? Tell me. This is nothing but core. Okay, so core, molten core, right? So this core is having very high temperature. Okay, this core is having very high temperature. So what they have told now, sir, with proof known, sir, Nobel Prize. Yeah. So if you're gonna find with proof, right? No one have went till core. So what exactly happened? Now they have given that this core is that much heat. Whatever the surrounding that is present over nearby the core is gonna get charged electrically. Okay, what is happening is gonna get charged electrically. Okay, now what's going to happen is once the nearby charge is going to get electric, how can you visualize this, guys? Have you ever feel kind of energy nearby, like when you are nearby the suppose some fire and you are nearby the fire? So can you able to feel some kind of heat in your hand, right? Can you able to feel, right? That is the way how heat energy is transferred in air, guys. So it is been aired using electrical convention. What we used to say, electric convention. No need to go that much deeper. Have an idea that using electromagnetic radiation, they try to travel the heat energy. Okay, so what happened, since it is too much heat, so there are lots of convention. So whatever the magnetic field that is present over here is produced all due to the molten heat at the center of the core. Okay, so they have assumed that whatever the, so how they have assumed, why they have told. Now you will be asking, right? Suppose if scientists is coming in front of you and telling that due to the heat the magnetic field is producing, obviously you are gonna ask, right? Na ki sir, how you are gonna produce, how it is gonna produce the magnet? So that is what scientists have not yet explained yet. Okay, yeah, air convention, yeah. So scientists have not till explained it, how they have made it. Okay, so I don't know why we call this a pen, but lots of people are telling this pen, so I am also telling it pen. It is going like that. So what they have find it now, there are different kinds of galaxies present in our space, and different kinds of stars also present in our space. Okay, so they find it out that each of the galaxy, each of the stars, they also have some kind of molten heat thing in their middle of the core, and all the cores are producing what? All the cores are producing magnetic field. Other than magnetic field, they could have produced, but we don't know till now. We are just talking about magnetic field lines because we are running just after. Have you got an idea? So what that scientists have done, they have tried to make a similarity with the Earth, with the Jupiter, with the Neptune, with the Mars. They find it that, oh my God, Mars is also having magnetic field. Jupiter is also having magnetic field. They went outside the stars. Let's talk about nebula. Okay, nebula is also having magnetic field. Have you got, are you getting ideas? So they try to find out in different stars. They got to know that each of the star is having same property. That is, they are having some molten amount of core. And due to that core, that due to the air convention and lots of cosmic rays, they're trying to produce magnetic field properties. Okay, so they just have explained that due to the core, they're producing magnetic field properties, not magnetic field, guys. Okay, due to core, they're producing magnetic field, different kinds of galaxies. So I hope this is the basic revision that I have give you till now in this chapter. So today we'll be learning very interesting things with respect to this chapter, guys. That will be a much more better. So let us start with respect to the earth magnetism, right? So shall we proceed, guys? Okay. So please ask your friends to join the class if they have not joined. Okay, let's proceed, guys. So as you can see, this is how the earth magnetism look like in reality. Okay, I will also show you one video to make it visualize much more better. So can you able to see the earth magnetism in reality? So basically when we talk about earth, there are 2 to 3 different things you need to keep in mind to visualize it in a better way, guys. This, okay, so first you can see, can you see the compass in middle, right, guys? I hope everyone can see the compass in middle. The meaning of compass is nothing but displaying you there is south pole over here and there is north pole over here. Can you, oh okay, they are trying to show in opposite direction. There is north pole over here, there is south pole over here. Can you see? Can you see? So can you tell me what is this line, guys? So we used to say this line is nothing but either, so I have told you guys name of this line. Can you tell me? Either magnetic meridian. So we don't talk magnetic meridian. We told that this is nothing but magnetic field line. Okay, or we used to say that this is nothing called magnetic axis. In other words, we say that this is magnetic axis. Okay, students. So you can see that it is originating from this point. But from the center, there is one more line is passing. What is this? Tell me. What is this geographic north? This is called geographic axis. Geographic axis. Let me tell you the difference. Let me tell you the difference. Okay, students. So the difference between them. Very good. If you wanna write it down, write it down. Don't tell this as meridian, guys. Meridian is something else. Okay, meridian is plane. When we talk about axis, axis is line. Okay, so if I'm telling that this is a cylinder and it is rotating, obviously the axis could be passing from center. Axis is a line, but meridian is a plane. Okay, write it down. These all things very important thing learning first time in your life. So that could lead to confusion. Okay, axis is a line, but meridian is a plane. Meridian is a plane. Okay, we have 2 major important factors that you need to keep in mind is nothing but See, so suppose if this earth is rotating, our earth is rotating, everyone knows, right? So the earth is rotating about a particular axis. Can you tell me which is the axis earth is rotating? Is earth is rotating about magnetic axis or earth is rotating about geographic axis? So how I try to understand this term? Very good, Nandis. I want every one of you to understand this. So as you know that earth is rotating about the geographic axis. Okay, it is not rotating about magnetic axis. If you're gonna find it out, how I try to visualize this, by the name only you can visualize it in a better way. Okay, as you can see in the name, what they have written, guys, they have written nothing but geographic. Geography, have you ever learned geography in your class 7, 8, 9, right? You have learned about 6, 7, 8 geography chapter was there. So you know that geography chapter deals with what, guys? They deals with the places. Okay, they deals with the places. Very good, social science. So they deal with the places. As you know that there are places. So when I'm talking about geographic North Pole, the meaning means there is a place in Earth that is, we say that this is nothing but our North Pole. And there is a place in Earth, we used to say this is nothing but South Pole. So we directly don't say North Pole or South Pole. We say geographic North Pole and we say geographic South Pole. None of the human being till now able to reach this place. It is just an imaginary place, but it is present there in Earth. Okay, it is an imaginary place. It is present in Earth, but none of the human beings have reached this place, because these places. So can you tell me what could be the why someone could not reach this place? What could be the thing why someone could not reach this place, guys? Tell me, guys. Tell me. Chilled. Wow, very good. So actually, what they find it out that at the magnetic, at the North Pole and the South Pole, not magnetic, geographic. At the geographic North Pole and at the geographic South Pole, the environment that is present over there is extremely cold, right? Extremely cold means it is very extremely cold. Okay, so even though they try to go nearby Antarctica, but they have never tried to find out, okay, this is the point where the North Pole is. Not minus 40, Nandis. Minus 40 is you can find in Moscow. I have been to Moscow, guys. And minus 40 is a common temperature, Nandis. If you go to Russia, you will find out that the minus 40 degree, minus 50 degrees is a common temperature. You will find out outside the environment. In India, temperature is very good. But when you go to different countries, you will find out the temperature is going to change very drastically. Okay, so I have been to Moscow airport. There was interesting. Likita, we will talk about that at the end of the class. Why I have been to Moscow. Okay, I have been for Moscow for my study only. Don't worry, guys. Okay, now that's an interesting thing. So let me tell you guys. So the temperature over there will be minus 270 degree, minus 300 degree, or minus 120 degree, like that. It will be too cold. Even though you go over there, right? The internal part of our body will get freeze. Okay, as you go outside, what happened in the space? You can find it at that like your body don't sustain in space without the space suit, right? So like that, your body will not able to sustain without a proper amount of suit at the North Pole and the South Pole, even though we cannot able to solve. Okay, guys. So line passing through these two poles will be called as nothing but we call this line as geographic axis. Keep that in mind. Line passing through if you want to write it down, write it down. Line passing through the North Pole and South Pole is known as geographic axis. Now, what? Now, the second thing. Okay, it is clear to each and every one of you guys. It is clear now to each and every one of you, right? Okay, good. Now, what we're going to understand, if I try to keep a compass, if I try to keep a compass in my earth, okay, so what they have seen, scientists have seen, the compass is not passing through that point only where geographic north is there. Are you getting my point? Compass is not passing. So tell me, suppose if I'm talking about a circle, so according to the compass, this is the center. So if the earth is rotating about this axis, so according to the compass, the north, suppose this is south pole, this is my north pole, guys, and this is my south pole. So according to the compass, my compass needle should also show here, right? Yeah, all are there, all are there in imagination, sir. Yeah, all are there in imagination. We can't see magnetic field lines. I will show you one video, very interesting video, guys. Don't worry. After this one, try to understand it, make your points, and keep in mind, because this chapter is very easy chapter, only conceptual chapter, and with respect to need, they directly ask questions, guys. So I don't want you to lose marks here. Okay. NMP is found now. I don't know about NMP. What is that NMP? Okay, so you find it out that when you put the compass needle is not gonna show in the north pole. Okay, what is gonna show? It is gonna show somewhat different angle, guys. What is showing? It is showing at somewhat different angle. That axis we called as magnetic axis. What we call? Means north magnetic fold is fine, guys. We can easily find. I will tell you interesting fact, Nandis, don't worry. I will tell you with result. So first try to understand that the axis from where the magnetic field lines are originating is known as magnetic north pole, and the axis where the all the magnetic field lines are entering inside the earth is known as magnetic south pole. You can see south magnetic pole and north magnetic pole. Obviously, so this magnetic axis and the geographic axis, they are not on same line, guys. Scientists have find it out. Okay, they are not on same line. You can see the angle between them. The angle between them is almost 11.5 degree. This is the accurate angle. So if you will find out that there is almost 11.5 degree of change in angle. Okay, so there is almost 11.5 degree of change. Sir, why that difference? That difference is coming due to 2 to 3 main factor. Okay, Nandis. So let me tell you the difference. Okay, so let us go ahead. Let us go ahead and try to understand. The difference is coming due to the Earth magnetic field is not passing from the magnetic geographic North Pole. Are you getting, Nandis? So I can tell you using a square box. Suppose, guys, you are having a square box. Okay, so according to you, the geographic axis will be what? Tell me. If suppose this square box is rotating, so according to you, the geographic will be somewhat like this, right? Passing from the center. According to you, if it is rotating like this, if my square, or suppose this is my phone, guys, if he is rotating like this, obviously the axis in which he is rotating will be passing from center, right? But what exactly? So obviously the geographic, so we used to write geographic axis. Geographic axis is passing from center, and it is pakka that it is passing from center. Okay, but what happened to magnetic? When scientists try to find it out, they find it out that no, it is not passing from center only. It is passing from center, but it is not passing from the geographic axis. It is passing from an angle that is a bit different from this axis. And reason of this changing of angle is affecting on different factors, guys. How far is earth from sun, and how our magnetic field lines is there, right? So this angle is almost, so this is called magnetic axis, and all angle is almost 11.5 degree. Direct question have been asked in other competitive exams other than JW and NEET, that how much is the angle between the magnetic axis and the geographic axis. If you're gonna keep in mind, you can easily remember it. Okay, is it clear, guys? Is it clear to each and every one of you? Till this, the points are clear to each and every one of you. Please let me know in the chat. Guys, is the points are clear to each and every one of you? Please let me know in the chat. Any students having any kind of confusion, just let me know, guys. I'll try to make you understand. Yeah, 11.5 degree. Yeah, that's correct. Even though you can convert this degree in radian, guys. Good to see most of you are replying. Now let me tell you that how, sir, if magnetic field will be there, then if I keeping my pen like this, my pen should float, right? Means if I'm saying that I am having some kind of metal, and if there is magnetic field over here, it should float. Right, guys? Magnetic field is there, it should flow. Why? Why is the reason it is not flowing? The reason it is not flowing is our earth is very huge, and with respect to earth, the magnetic field that comes across to us is a very small quantity. You can see the quantity in which the magnetic field is coming, 25 to 65 micro tesla. Not poles are not weak, Nandis. Poles are not weak, poles are very strong. Okay, Nandis, poles are very strong, but whatever the strength that is coming till us, okay, might be it is 1,000 kilometer away from me, right? So whatever the things that is coming towards us is only very less in magnitude, only 25 to 60, 25. So 25 micro tesla, guys. So 25 multiplied by 10 to the power minus 6 tesla. You can see the quantity is very less, right? Sir, as a magnetic field lines arise in the North Pole, but in case Earth, why we are entering into the magnetic North Pole? We are not entering magnetic North Pole. Oh, don't treat, guys. See, student Soumya, different books represent different techniques. Okay, different books. So in this book, they will be representing this as South Pole. Okay, this is South Pole, this is North Pole. So different books represent different techniques. So don't get confused over here. Have you got it, Soumya? Just keep in mind that from the poles from where the magnetic field lines are coming out is known as North Pole, and the pole from where the magnetic field lines are coming inside is known as south pole. So these are two are different pictures, guys. So don't get confused, guys. Okay, they have they very clearly mentioned that over here north pole is above, south pole is above. Over here, don't assume that okay, north pole will be always up only, right? So they have made it like that to make us understand, guys. Is it clear? So you can see the value of magnetic fields are very less in quantity. That is 25 multiplied by 10 to the power minus 6. So that is the reason it don't affect our body too much. Okay, and if it affects, it will lead to radiations or something like that. Okay, so let us move ahead and try to see one video, guys. This is an interesting video. I want everyone you to concentrate the video and visualize huge connections, sir. Yeah, lots of huge connections are there. I want everyone you to see the video carefully and keep the points whatever you are trying to understand. A Tesla, those two are units only. Nandis, those two are units only. Those two are units only. Okay, one Tesla is almost 10 power something, some power. I'll tell you. Don't worry. Okay, so let us launch the video. Try to watch the video carefully. So did sir have made you shown this video? No, right? Okay. So if sir have shown the video, then it is very good. If sir have not shown the video, so this is how the magnetic field lines look outside the Earth, guys. So as you can see, when you are moving, this is the video taken by NASA by Hubble telescope. Okay. So let me show you. So you can see the magnetic field lines are producing due to it's imaginary, na? Yeah, it's imaginary, Nandis, it's imaginary. You can see there is a molten core, and due to this molten core, what is happening? The scientists imagine that there is going to be magnetic field lines coming outside from it. Now let me show you that how the magnetic field lines are. This is the real picture and real view of magnetic field lines. They have not found it, they have assumed it, Nandis. This is just an imagination. Okay, so you can find that if this is the Earth, this is how the magnetic field lines are presenting over. Can you tell me why the magnetic field lines are going over here like this? Can anyone tell me why the magnetic field lines are going over here like this? Tell me. Try to participate, guys. Interesting one. Why the magnetic field lines are going at the back side? Why it is not tangent, not to south. Earth is rotating. No. It is happening due to so guys, have you ever tried to keep a magnet in front of magnet? Suppose if I have a magnet that is having north pole and south pole, and if I'm again trying to keep a magnet that is having south pole and north pole, obviously I'm going to keep. So what is going to happen? Tell me. They're going to repel, because unlike like charges repel each other, right? So you can find that due to the magnetic field of sun. So there is something called sun over here, guys. So if Earth is having a magnetic field, think about sun. Sun is full of molten core. Sun is having on his surface also there is lots of molten core. So sun will be having that much strong amount of magnetic field. Yeah. So think about it, Sachin. So sun is having that much strong amount of magnetic field that it try to holds my Earth, Venus, Jupiter, Mars, right? So you can see lots of big planets are inside the magnetic field of Earth, right? So inside the magnetic field of sun. So you can find it right that these are all the, even though this is very less, guys, there will be something like this also. So in the front also. So what these magnetic fields are helping us, since there have been millions and billions of kilometers surrounded in my space, if there is repulsion, then there should be attraction. Yeah. Attraction and repulsion are going on these. That is the reason why my Earth don't rotate circular. That is the reason why you find seasons. Do you have rainy seasons? Do you have summer season? So why that is happening? Because sun is there and Earth is rotating in an elliptical path, right? Gravitation chapter, I think so. You have not did, right? No problem. So there is something called gravitation chapter. So Earth, so when it is nearby, we find summer. When it is far, we find winter. Right, guys? So why this is coming near and far? That is all how the Earth sun magnetic field is affecting. Okay, everything is not. So guys, we are telling that we treat Earth as a bar magnet. Don't assume that Earth is actually a bar magnet. This is just an assumption. Mass is directly proportional to magnetic field. You can say like that, but not totally. It depends upon charge. It depends upon quantum level. Okay, in quantum level, you can say that mass is directly proportional to magnetic field, not so the not the actual level. Okay, so actually, when we talk about in mass, Earth is having a very big mass, sun is having a very big mass. So you can find that the magnetic field around each is very big. Is it clear to each and everyone? So let me show you few. Let me run the video for more time, and then we're gonna proceed ahead, guys. As you can see that magnetic field, how it is affecting, right? Guys, any sir, geographic mean and MF both means north. NAS Nandis, I'm not understanding. What is NAS Nandis? Means that is too short. Okay, guys. So actually, you can watch this video. I will share with you, and you can check it out. So you're gonna find that the axis in which my Earth is rotating. Don't worry about sound, guys. Don't worry about sound. So in the axis in which my Earth is rotating is called rotational axis. Okay, is called rotational axis, and the axis from where my magnetic, where my magnetic north pole is there and south pole is there, is known as magnetic axis. How much is the angle between them, guys? As I have taught you, the angle between them is nothing but 11.5 degree. The angle between them is nothing but 11.5 degree. Sir, what is South Atlantic anomaly? You don't need to learn these all things. This is a NASA video, guys. Actually, this video is trying to explain that there is some kind of dip in magnetic. Okay, so don't worry. I'm not going to teach you those things. Don't worry, guys. Jayant. Okay, so don't worry about South and Atlantic anomaly. They are trying to say that from the South Atlantic anomaly, this is how they went too much deeper actually. Okay, just try to. Anomaly means how we try to correlate the things. Okay, anomaly means how we try. So as I taught you these things, guys, this first one, can you see? So what is this? This is the anomaly between electric field and magnetic field. Okay. Yeah. So just a minute. Okay. So you can write analogy and anomaly. ANAMOLY. Anomaly between magnets. So how we try to correlate the things? I can say this is my pen, this is my pen. There is some kind of analogy between them, right? Obviously, these two pens do different. This pen I cannot write in wood, and this pen I am writing in my tab, right? So they both are having some kind of same structure. The property is same that we can write, but the use is different. Are you getting the idea? I hope you guys have got a little bit idea. Video continuation, sir. There is no continuation for the video. You can watch it out after the class. Guys, I'll share the video with you. It is a very small video, 2 minutes video only. So you should just keep in mind that there is something called rotational axis and magnetic axis. If these things are clear, guys, let us proceed ahead and try to understand that what is the meaning of rotational axis and our magnetic axis, right? So we're gonna talk about few things, guys. Okay, so let us go when deeper in earth magnetism. Okay, so please keep those two things in mind. That is, we have something called geographic axis and we have something called magnetic axis, because those things we'll be using after this. Okay, so in earth magnetism, there are two types of concepts that you're gonna learn, and questions have been asked using these two concepts only. The first concept is called angle of dip. What you call? You call angle of dip. Angle of dip, right? Angle of dip, or the second name of angle of dip is also called inclination. Okay, so lots of students get confused that they talk about angle of dip and they talk about uh, angle of dip and angle of inclination. In some books they will write either angle of dip. In some books they will write angle of inclination. In some books they will directly write directly inclination, students. So keep this in mind. And then the second important parameter is nothing but angle of declination. So we have these two important parameters, guys. So today we'll be totally and mainly focused on angle of inclination, angle of declination. Are you guys understanding the concepts, right? What I'm trying to make you understand? Both are same, no, sir? Yeah. So angle of dip and angle of inclination are same. Angle of dip or angle of inclination are same, but angle of declination is different. Let me tell you how it is different. Analog compass. Let me show you how it is different. Nandis and Hema. Try to understand it and write it down. When I talk about angle of dip, generally what we used to do is angle of dip is with, as you can see, inclination, guys. Inclination is with respect to the horizontal. Inclination is with respect to the horizontal. Can you able to see and visualize? It is trying to find a dip with respect to the horizontal. That is the reason why I'm calling this as angle of dip. Okay, dip means there is compass, and compass is gonna go like this. I will show you one video, don't worry, but try to understand it that angle of declination is with respect to the horizontal, okay, with respect to the horizontal. And when I talk about angle of declination, it talks with respect to the vertical. Keep these 2 points in mind, only these 2 points, okay. So what we used to call nothing but angle of dip is with respect to the horizontal. Okay, guys, it is with respect to horizontal, and angle of declination is with respect to the vertical. Now, let me tell you that how you try to find this. Okay, let me tell you how to try to find this. Okay, so let me show you one video, guys. So this video, tell me whether he's trying to find angle of dip. I will mute. I will not tell you. I will not show you. I'll run the video. Tell me that whether he's trying to find angle of dip or he's trying to find angle of in declination. Just watch out and tell me. I'll give you 1 minute time. Don't worry. Just watch out and tell me. See how the compass looks, how the scale is there, the round scale. You might have never seen such kind of device, but it is a device that helps us to measure. Okay. So just try to understand it and tell me the answer that whether he is trying to find angle of dip or whether he is trying to find angle of inclination. So tell me what you have just now find it. Tell me, guys, what you have just now find it. Just now you have find it out something. Can you tell me what you have just now find it, students? You have tried to find something. Tell me what you have just now found. You can see that it has rotated. He have tried to rotate his own apparatus and it is very good, very good. Most of the students are saying declination. Very good, guys, very good. So as you can find that just now when he kept his compass like this and when he tried to rotate the compass, he find it no angle of dip. Impana, I can see that few students are giving you wrong answer. Okay, okay. Let me show you the angle of dip also. So this is how we used to find angle of dip. You can see what he have done. Let me show you the video. Okay. So you can see what he have done is he will try to rotate the compass. Okay. He will try to rotate the compass. See what he have done. He have tried to rotate the compass. Now, when he rotated the compass, you can find that the compass is not going like this 90 degree. It is going at a particular angle. It is going at a particular angle. Right. So how much angle he have been went down is known as angle of dip. Is the angle of dip is clear? That is with respect to the horizontal. That is the reason why I have written that angle of dip is with respect to the horizontal. Is it clear, guys? Please tell me. Is it clear? Have you got a conceptual idea? I am not telling you any formula. I'm just giving you a conceptual idea. That is my major factor. Angle of dip. Is it clear? Tell me. Angle of dip is with respect to the horizontal. You can see that with respect to the horizontal, the term that is yeah. So you can see that term that is with respect to the horizontal is nothing but different. The term with respect to the horizontal is nothing but different. Sir, angle of dip is 60 degree in video. No idea. Yeah, I will share these videos, guys. Don't worry. Okay, just after the class, I'll share. So you can see in order to find angle of declination, we need to keep our compass like this, and it is gonna rotate like this, guys. It is gonna rotate like this. I hope you can visualize. It is gonna rotate like this. Okay, and when we talk about angle of dip, it is gonna, so both the compass are there. It is gonna rotate like this. There are two different structures. Okay, so for angle of dip, my whole axis has been changed. It has come to this axis. For angle of declination, my whole axis is in this level. So this is the reason why they used to draw such type of diagrams. This is without audio. If you want to see the audio also, audio is nothing like that, guys. Nothing important in audio in this actually. So I'll show you from starting. Watch it out. It is a 1 minute video. Understand it. Yeah. So what he have tried to done? Tell me. He have tried to rotate, guys. So what is the use of that rotation? Can anyone tell me? So don't worry. Just try to understand today. Might be next to next class. I will make you understand. No audio, sir. Okay, Ramesh. I think so. Audio will be not shareable. No problem. I will. Yeah, very good. So I will try to share the video in the class, in the WhatsApp group. Okay, please watch the video. Okay, so basically he's trying to do what? He's trying to rotate the axis. He's trying to rotate the axis, and he got to know that in every axis there are different angle of declination. So this is the way of measure to find angle of declination. Please write it down and have an idea so that you can visualize the things, guys, because most of the things in this is imaginary. Okay. Okay, good. And in order to find angle of inclination, you need to move it in horizontal axis. You need to move it in horizontal axis. You can see that it is moved in horizontal axis, and he is trying to find angle of inclination. So that is the reason why they have written over here. So when we are talking with respect to the horizontal, it is making an angle I, right? And when we are talking with respect to the vertical, it is making an angle like this. So that is why we call this as in vertical, and we call this as an horizontal. Is it clear? So guys, they have made the diagram in different pictures. So you can see this is the top view. This is the top view. Okay, and this is the side view. They both are different views. So no, you should not get confused. This is a side view. From side, your compass will go like this. From top, your compass will go like this. So I hope everyone can do. So if I rotate my compass like this, what is this? Tell me. So I'll just make my picture like just a minute. Yeah, just for your sake of reference, I will try to add one thing so that you can, I don't need any blur, right? That is good, right? So you can see guys, as I'm moving my hand, yeah. So if I'm trying to rotate my pen like this, if I try to rotate my pen like this, what is this, students? Tell me please guys. If I'm trying to rotate my pen something like this, what is this? The meaning of this is nothing but angle of declination. Okay, and if I try to rotate my pen like this, if I try to rotate my pen like this, it is angle of inclination. Angle of inclination is with respect to the horizontal. Suppose this is my horizontal axis. With respect to my horizontal axis, how much he have came down. And angle of declination is with respect to the top view, guys. So from top view, this pen is going to rotate like this. I hope you can visualize and you can do by yourself. Right? So is this comfortable to visualize angle of dip and angle of inclination to each and every one of you? Just let me know in the chat if anyone is having any kind of confusion. Just let me know in the chat, guys, if anyone is having any kind of confusion, because this is the basic understanding you should have. Okay, guys? Everyone is comfortable to understand? Any confusion, just let me know. I'll wait for 30 seconds and then we can proceed ahead. Once more again, Ramesh, see, when we're talking about angle of declination, when we talk about angle of declination, you can see that the angle that he's trying to rotate is with respect to the top view. Top view means you're trying to watch it from top. You're trying to watch it from top, right? So you can see that my whole plate is it is just looking like my whole plate, right? So you're watching your plate from top. So this angle is going to change with suppose this is my reference line. This is my reference line. So how much angle you have declined? So this is called angle of declination. Can you able to visualize now, Ramesh? Can you able to visualize now? So he have tried to rotate this much angle. He have tried to rotate this much angle. This is how you can visualize. Got it? So at equator, at my north pole, at my south pole, there are different kinds of angle of dip and angle of declination. I will go one by one, but first of all, you need to visualize that what is actually angle of declination. Okay, so actual angle of declination is with respect to the vertical, how he is trying to rotate, how my compass or how axis is trying to rotate. Okay, and when we talk about angle of inclination or dip, angle of dip, right? So angle of dip has been explained using this term. So I have tried to rotate my whole compass. You can see how I have rotated my compass. Watch it out. I have tried to, so I'll try to solve. You can see that I have tried to rotate my whole compass, right? So rotating my whole compass is going to make the compass angle with respect to the horizontal, right? Can you be able to visualize? So you can see that from with respect to the horizontal, it have moved this much angle ahead, right? So this is nothing but angle of dip. This is nothing but angle of dip. Is it clear, guys? Is it clear? Sir, angle 90, na? No, it is not 90 in this. It is not 90. It is not coming 90. And this is what scientists have found it out. And this is the reason why the magnetic North Pole and magnetic South Pole are in different. No, the turning angle. No. Turning angle changes with place to place, guys. Okay. Our turning angle changes with respect to place to place. So on my Earth, right? My Earth is a whole sphere. Sir, it is not. So I am not changing the place, right? 11.5 degree. No. Angle of dip is not 11.5 degree, Hema. Angle of dip is not 11. That is just general case, Hema. That is with respect to the axis. Okay. If you are going to this place, angle of dip will change. If you're going to Africa, angle of dip will change. If you go to South America, angle of dip. If you go to London, the angle of dip will change. If you go to Moscow, the angle of dip will. This is the reason why we different countries are having different kinds of like the gravity value is nothing but 9.8, right? But if you are there in India, there is huge possibility that gravity value is 9.812. Or if you are there in Africa, there is a huge possibility that gravity value could be 9.8001. Right, so there is 9.8, but after that 9.8 there are lots of possibilities are changing with respect to the gravity and magnetic field. So it is not uniform everywhere, guys. It is changing. Okay, it is changing. So the magnetic field is changing with respect to place. The angle of dip is changing with respect to place. Now I will teach you guys, don't worry, how to find angle of inclination. Okay, there is a very easy formula to find it and you can comfortably understand it. Okay, when we talk about angle of dip is also called angle of inclination. Some of the students do wrong over here only. They think that dip means declination. Wrong. Don't think dip as declination. That apparatus have turned 90 degree. So that is the reason why I'm talking about. That is the reason why I'm talking about horizontal and vertical. Okay, that is the reason why I'm talking about horizontal and vertical. If you're trying to find declination, you need to be there in vertical axis. That is from top view, right? Vertical axis. And when you are there in inclination, you need to be there in horizontal axis. So this is my horizontal line with respect to horizontal and how much he's trying to get down. So obviously from going from vertical to horizontal, you need to move 90 degree. So that is the reason they have moved the compass 90 degree. Okay. It's a 360-degree compass. Right. Okay, so when I talk about angle of dip and angle, so before talking about angle of dip and angle of declination, guys, let me tell you about a very interesting thing. What do you understand by geographic meridian and what do you understand by magnetic meridian? So as you know that, suppose if I am having a earth, students, this is my whole earth, right? So this is the point from where, this is the point, I'm very sorry. This is the point from where, this is the, this is the point from where I have geographic axis, and this is the point from where I have magnetic axis. This is magnetic axis. MA means magnetic axis, GA means geographic axis. The angle between them is nothing but 11.5 degree. 11.5 degree. If you are standing there, when the angle is 11.5 degree, if you are standing here, right? If you're standing, if you're taking at the equator or if you're standing at the center, got it? Are you getting my point? But if you're standing at the center, then only you will be getting 11.5 degree. This is the angle between the magnetic field axis and the geographic axis. But what will happen if you're there in London? Suppose this point, P point is London. Okay, if P point is London, so how I'm gonna talk about this? Okay, so first of all, we don't talk in axis, we talk in meridian. Okay, so what do you understand by meridian? As I told you that meridian is nothing but plane. Okay, meridian is nothing but plane. So as you can see, they're writing geographic meridian. So how can you visualize geographic meridian? So first of all, geographic meridian is nothing but geographic meridian is a plane that passes through the geographic axis as well as the point from where we are trying to find. Write it down. Geographic meridian is a plane that passes through the geographic axis as well as the point we are trying to find it out. So you can see in this diagram, where can be my geographic meridian, guys? I'll be using same color. Okay, so you can see this is how my geographic meridian will look like. This is how my geographic meridian will look. Can you able to visualize? So this is the plane. So plane means x axis and y axis. Plane means something like this, right? That is the reason why they have drawn the circle like this. So if they are talking, so this blue plane is also passing from point P. Okay, guys, this blue plane. So why that square? You can make triangle, rectangle, square, trapezium. Other than that also you can go. That square makes us comfortable to understand. That is the reason I'm making square. Okay, none other than that anything. Means I'll draw the same diagram in another page, in this page only, but in a proper view. Okay, so you can understand it in this picture. Actually, I have put it that picture or not. Let me just check. Okay, we don't have that picture. Okay, no problem. So let me show you guys. So what we're gonna do is we're gonna have Earth. With respect to my Earth, I have my point P. This point P is, what is this point P, guys? Tell me. What is this point P? Tell me. Point P is the point where I want to find my magnetic field. Point P is the point where I need to find my magnetic field. Okay, London. You can say London. Let me write London. London is comfortable to understand, right? So point P is any random point. It can be London, India, Africa, USA, any place. I don't care. But I care about that it is a point on Earth. Okay, so this is my center of the Earth. So with respect to my center of the Earth, this is my axis, that is nothing but geographic axis, guys. So if I'm talking about geographic axis, then I will say that my geographic meridian will be the square place which will be passing from this point also, which will be passing from this point also. So this is how my geographic meridian will look like. Can you able to visualize now? Is this comfortable to visualize? So it is nothing but a plane. It is nothing but a plane. I hope everyone knows what you call plane. It is nothing but a plane which is passing through that London also, which is passing through that London also. That is the reason why they have prepared the geographic meridian like this. This is the reason why they have written the geographic meridian like this. It is nothing but a plane. Okay. And I will use red color. Okay. Now magnetic meridian. So first of all, let us try to find magnetic field axis. Right. So, sir, definition of geographic meridian. Harsa, I told you, right? So if you want, I will write it down. I will write it down over here. Geographic meridian. It is a plane. It is a plane which passes. It is a plane which passes through geographic axis and point P. Point P is the point where we are trying to find the magnetic field, like equator, not like equator. You can take a point on equator also. You can take a point on Antarctica also. Equator is just a line that is passing from the center. Okay, that is dividing. And when we talk about this is geographic meridian, when I talk about magnetic meridian, it is a plane which passes through magnetic axis and point P. Is this comfortable to understand now? This is comfortable. So you can see that if my magnetic field line, so suppose this is my magnetic field line. Okay, this is my magnetic field line. So obviously my magnetic field axis will be somewhat looking like this. My magnetic meridian will be somewhat looking like this. So do you think that the diagram is going too much clumsy? Do you think the diagram is going too much clumsy, right? So you can easily see that the diagram is going too much clumsy, but it is there, guys. So does it pass on G axis? Geographic axis? No. None these. So magnetic meridian is only gonna pass from magnetic axis and point P. Geographic meridian is only gonna pass from geographic axis and point P. That is a common terminology. The red one is called magnetic meridian and the orange one is called geographic meridian. In order to view this in a simpler way, they have tried to maintain it like this. Suppose this is the plane. Suppose, guys, this is the plane for my geographic meridian. This is a plane for my geographic. That is the reason. Geographic meridian, and this is the plane for my magnetic meridian. That's why they are trying to make square and make you understand, guys. This is the reason. And this plane is called magnetic meridian. So obviously there will be some kind of angle between them, right, students? Sir, they will be have same point on equator. No, sir. Yeah, Hema. On equator, you will be finding that the value will be changing. So we will come. Don't worry, Hema. We will come. So as you know that it is nothing but dip or inclination, right? So you're gonna find few angles, guys. So there are two things. So can you tell me what is this angle? Can you tell me what is this angle, guys? What is this angle? Tell me. The above one, guys. What is this angle? Tell me. The upper one. So you can see that this is my copy, guys. I hope everyone can see the copy. Wait, I will show you the copy. Okay. So just a minute. Yeah. Now it's fine. So I hope everyone can see my copy. Right? So can you see the copy, right? So this is my copy is just looking like this, guys. Right? Can you see the copy? So one of the axis is nothing but, so this axis, suppose this axis we are talking, this axis is called magnetic meridian, this axis is called geographic meridian. So there are two types of angle that is being present over here. One angle is the top angle, guys. So what do you call top angle, guys? Tell me. Top angle. I hope you can visualize the diagram. So only one students have replied. Where are other students? Declination. The top angle will call as declination. Very good. Very good. So is it comfortable to visualize now? So if anywhere that kind of diagram has been presented in front of you, you can very clearly say that, oh, this angle is nothing but declination, right? This angle is called declination. Also written by D. In some books, they will write theta. In some books, they will write theta, guys. Keep that in mind. In some books, they will write theta. Okay, or this theta is called declination. Now, where is angle of inclination that? So do angle of inclination. Yeah, Nandis, you are right, Nandis. Nandis, you are correct. Am I right? Sigma. You are correct, Nandis. Very good. So where is then angle of inclination? So angle of inclination is something like this, right, guys? Angle of inclination is something like this. So something like this means, obviously, suppose the magnetic field vector is gonna come in this direction. I'm using red color. So magnetic field vector is gonna come in this direction. We know the axis is somewhat right. Dip is sigma. No, 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 no. I cannot say like that. Different books use different terminology. Some books they use declination as I. In some books they use declination as also as delta. Okay, some books they write I, some books they write sigma. So in my in over here it is not this is delta. This is not sigma. This is delta, guys. Keep that in mind. This is delta. Don't call this a sigma. Okay, theta. Okay, so you can see that angle of dip or angle of inclination is nothing but how much is the angle it is making from the top one. How much is the angle it is making from this point, right? So I hope you can visualize now. So this is nothing but delta. Okay, so tell me, suppose this is my earth magnetic field. This is my earth magnetic field. Sandeep, can you tell me which point you have not understand? Can you tell me which point you have not understood? May I know which point you have not understood? Sandeep, so it will be more better. Okay, I'm going to explain again. Watch it out carefully. You can see that top view. Okay, top view, Sandeep. Watch your copy, Sandeep. This is how it looks, guys. This is how it looks. So this is my point P, students. This is my point P. So this point is my point P. You can see my copies have this is my copy. My copy have been opened like this. This point is my point P, that the point London. This point is my London. So from my point P, I have two vectors. One vector that will be going through magnetic meridian, and one vector will be going to geographic meridian. So you can see I have two vectors. So two square plane surface. One vector will be going to geographic. So there are two types of angle. One angle is the top angle. This is the top view. This is the top view. Can you see the top view now? So is there any angle between these two planes? So this is my geographic meridian. This is my magnetic meridian. Is there any angle between these two planes, guys? Tell me. Yes, there is an angle, and this angle from top view is known as declination. Got it, na? Sir, theta is the angle of declination, and what is the angle of inclination? Angle of inclination is nothing but this is my copy, guys. Let me get more deeper. Okay, this is my copy, guys. With respect to my copy, what is happening is obviously I'm talking about this point. So it is not sure that my magnetic field will be where in which direction. My magnetic field will be in which direction. So we assume that magnetic field will be this pen, but we assume that magnetic field will be this plane. So can you see this is my magnetic field? Can you see that it is passing somewhere over here? I hope you can visualize from here. So it is not going like this. It is not going like proper down, or it is not going like this. It is at some angle, right? It is at some angle, and that angle is called angle of inclination with respect to the horizontal, how much it is inclining. That is what we have shown in that video. So why I have made it compass like that? In order to make the compass dip or decline. In order to make the compass dip or decline. Is it clear, guys? Let me know. Is it clear, Nandis, Sandeep, and other guys? Delta Naya. And this angle is called delta. This upper angle is called delta. So it's on which pole? Doesn't matter. Doesn't matter, Nandis. Doesn't matter. You take south pole or north pole. Doesn't matter. So you can first try to read this. So it doesn't matter pole. So magnetic meridian is nothing but from magnetic axis to magnetic axis to point P. It is with respect to that point P. We are not talking about pole. We're talking about this point, this point. So this is my London. So at my London, I'm standing, I'm trying to find that how much is the angle of declination. What I'll try to do, I'll go to this place, I'll try to use dip meter. I'll try to check, okay, I have made my, basically we used to do some kind of calibration also before, but I'm trying to make you understand now. I will try to keep my compass like this. It will try to show some kind of angle. I will get to know, oh, this is the angle of inclination. Okay, is it clear, guys? That 11.5 degrees, neither angle of dip, neither angle of inclination. So don't treat that 11.5 degrees something like that. So which is angle of inclination? Angle of inclination, I'm trying to make you understand, right? From that time only, I'm trying to make you understand. Watch it out. Angle of inclination is somewhat over here, guys. Okay, suppose if I'm standing over here. Okay, suppose if I'm standing over here, what do you think? Will there be any kind of magnetic field passing from me? Tell me. If I'm standing over here, there will be magnetic field. So let me talk about my hand, guys. Let me treat this is London. Let me treat this is London. Okay, this point is London. Okay, so if magnetic field will be passing from London, so I will try to represent magnetic field will be like this. Okay, I will try to pass, I will try to represent magnet. So this black pen is nothing but the magnetic field. So how much it is with respect to the horizontal? Tell me. So this is my horizontal axis, right, guys? This is my, I'll try to write it like this. I'll try to keep it like this. Oh my God, what happened? So you can see that with respect to my horizontal, this earth magnetic field is at some inclination, So this angle is called angle of inclination. Is it clear to each and every one of you? Tell me. Is it clear, guys? So it is angle between magnetic pole and geographic pole. And yeah, that is the angle between magnetic pole, magnetic axis and geographic axis on this. Amit, is it clear, Amit? So if you are standing at a normal point, obviously there will be one direction vector. So let me show you with respect to the vectorial term. So what we used to write is nothing but, suppose this is my magnetic meridian. Okay, this is, I will try to draw one diagram and make you understand. This is my magnetic meridian, guys. Okay, and I'll use blue color, and this is my geographic meridian. This is my point P, that is London. Okay, this is magnetic meridian. That is magnetic meridian. and this is GM, geographic meridian. The angle between them, this angle is called dip, the upper angle from top view, sorry, declination. So at this magnetic meridian, what will happen? There will be one kind of magnetic field, right? There will be one kind of magnetic field. So all the planes will reach at point P. Yeah, only one plane will reach at point P. How all the planes can be? There are an infinite amount of points. So if you're talking about Earth, then you can make infinite amount of planes passing from different places, right? So there will be some kind of just a minute, what happened? Okay, that's fine. Yeah, so you can see the diagram. So you can find it out that there will be some kind of magnetic field over here, which is represented by B of E. How you represent magnetic field? Magnetic field is represented by B of E. This angle is nothing called theta. This angle is nothing called theta, delta or I. This angle is called delta or I. Okay, this angle we used to call delta or I. Can you see or visualize the angle, guys? Is the angle is clear to each and every one of you? So you can see the angle goes like this. So this is my BE vector. And with respect to my horizontal, I'm getting this angle as nothing but delta. Can you tell me? Can you tell me that which is cos theta and which is sin theta? So we're gonna write this two components. We're gonna write two components of B. Yeah, B is scalar quantity. How magnetic field can be scalar quantity? Magnetic field is having magnitude as well as direction. So B is not a scalar quantity. B is a vector quantity. So with respect to B vector quantity, we're gonna have two directions. First of all, we will be having nothing but BE. Tell me BE. So this angle will be cos of delta, right, students? This angle will be cos of delta, and over there, so this is called horizontal component. This is called vertical component. So BE sine of delta. So we used to write like this. Is it clear to each and every one of you guys? Is it clear to each and every one of you? So what we're gonna write is nothing but we're gonna write B of E. So I hope now from here the formula is very clear to understandable, right? From here the formula is very clear, right? So you can directly say that if you're gonna write tan of delta, what you're gonna write? Tell me. So you're gonna write tan of delta will be nothing but B of V. So let me show you. So this is nothing but my horizontal component, and this is my vertical component, right? So I'm gonna do nothing but B of V by B of H. So what is B of B, guys? Vertical component. By vertical component is nothing but B sine delta. BE of sine delta, right? Divided by my horizontal component is nothing but B cos delta. BE cos delta. If I'm going to take ratio, I'm going to find that my earth magnetic field at that point is going to get cancelled. I'm going to get nothing but I'm going to get tan delta. Sine delta by cos delta is nothing but tan delta. And this is my formula, students. So tan delta, where delta is nothing but angle of dip. Delta is called angle of dip. Or you can write delta as I also, no problem. Delta can be also written as I also. Okay, so some books they use I, some book they use I, some book they use delta, some book they use theta. So don't get confused. Don't mug up the formula based on the terminology of tan delta equal to V by B, V by BS, tan delta. Don't do like that. Understand what is the meaning of that delta. That delta means angle of inclination. Okay, so if you're gonna find, so let me show you one interesting fact, students. If you try to find the angle of dip, if you try to find angle of dip at the equator, angle of dip, if you try to find at the equator, you will find it out that the angle of dip will be 0. The angle of dip will be 0. Means how my compass will be there? Tell me. If my angle of dip will be 0, then how my compass will be there? My compass will be total like this. My compass will be, tell me, students, angle of dip is 0. Right. So tell me how my compass will be there. Tell me. So that means my compass will be, is my compass will be passing from here? No, my compass will be directly like this. This is how my, so it will be total like this. So there will be no angle. This delta will be 0. Right. The angle of dip is 0. That means this I value is 0 at horizontal, at the equator. Questions have been asked, guys. This is at equator. Write it down if you want to write it down. So at equator, you will find that my angle of dip will be 0, but at the poles, at the north pole and the south pole, so no passing, no angle formation take place. Yeah, correct. So all the passes, but if you go to pole and find it out now, you will find out that the whole compass will gonna come like this, right? It is very comfortable to understand, right? So you're gonna find that angle of declination on a dip is nothing but 90°, right? 90, yeah, correct, 90. Let me show you the diagram and understand it. So when you take this instrument like this, I hope you can see the instrument. If you go to equator now, you will find it out that at equator, when they have north pole and south pole, obviously the compass is going to attract towards the north pole, south pole, and you're going to get the angle of dip, that is I value is equal to 90. And over here, when you reach at the equator, you're going to find that it is going to be parallel. It is going to come like this. So it is, the angle is going to come like this. Right. So there will be no angle of inclination. So it will be 0. Is it clear to each and every one of you to visualize and understand, guys? Is it clear to each and every one of you to visualize and understand? Very good. Parallel. So over here at equator, it is going to come parallel. But when you go to the top part, so please make sure you do revision. Take 5 to 10 minutes break and do revision of these concepts what I taught you today, because this questions directly, guys, directly the formula have been asked and questions have been asked. Okay, so I'm guys launching NPS. Everyone try to fill NPS. I have added few questions for you. Okay, guys. So you can try. So this is how the instrument look like. So previously, this is how the instrument looked like in earlier. Okay, so I have added few questions. Try to solve these questions. These questions are based on the, might be not today. Don't try to solve today. So the Monday I will try to do the revision of these questions. Okay, so make sure that you try to solve these questions. These are homework questions. Okay, homework questions. So not today, homework questions for Sunday. On Sunday, you're gonna try to solve these questions. Okay, Sunday homework question. Sir, sir, make some concept test. Nandis, you wanna some concept test? I can Sunday. Yeah, Sunday homework. Guys, tomorrow you will be having test. I want everyone you to participate in the test. Check whether how much you have understood that chapter on today's topic. Okay, sure, Nandis. On next class, I will try to make some content, some kind of concept test. Okay. Sure, sir. Bye-bye. Thank you so much, Arun. Guys, are you understanding the class? Is this comfortable? If anyone is having any kind of confusion, please let me know. I'm still here, guys. We have last 5 minutes. Please feel free to ask doubts. Don't be it should not be like, sir, why you have been to Moscow? Okay, I just need to. I have been to Moscow to my to do some experiments, Likit, to do some kind of research paper. Likit. So that research paper is, but sir, videos. Yeah, I will after the class I will send the video. So at the end of the class, ask some questions. Nandis, okay, sir, I actually put it this question in order to make you understand this. Can you tell me the answer of this? Try it out. Try it out. Can you tell me the answer of this? Try it out. In between, I will try to tell you. Sir, you deep weather at Moscow? Yeah, I was there at Moscow at that time in this. I was not there in Moscow. I was there in Germany. In my DP, I was there in Germany, Düsseldorf. I was there in Germany, Düsseldorf. Okay. And I have been to Moscow for some. Very good, Hema. Very good. Very good. So as you can see, the Hema have given the correct answer. Other students try to participate. If you have a bar magnet of length L and cross sectional area A, and if you're gonna cut those two pieces equal part, obviously how the pole strength of each pole change, it is gonna get half. So if you're gonna cut the magnet like this, students, very good. No, Arun, no. Good. So you can see that suppose if this is my magnet, okay, the pole strength is M and the pole strength is M, and this is north pole and this is south pole. I'm gonna cut the magnet. So what is gonna happen if I'm gonna cut a magnet? There will be two magnets. Okay, there will be two magnets. Okay, obviously the length will be become L by 2. The length will become L by 2. Suppose the initial length was L, so the length will become L by 2, right? And what will happen to pole strength? So pole strength will become M by 2. Both the sides will be having. So we'll be having north, south, something like this, guys. And we'll be having M by 2 and M by 2. So if you try to cut the magnet, the pole will get, right, the pole get half. Sir, it's a direct question. Na? Yeah, Nandesh, it's a direct question. So questions directly have been asked like this, guys. That's why I'm telling you this chapter is very interesting, and this chapter does not require more than 7 to 8 lectures. Okay, so it won't go too much long also, and very small chapter also, and very easy to understand. So make sure you don't leave this chapter, guys, especially NEET students, because NEET question have been directly asked from this chapter, and I don't want. Nandis, we are almost out of time, Nandis. So next class, I will sure try to make some kind of interactive session with respect to the questions. Okay, I will try to keep more questions. I think so 10-15 questions I will try to keep. Sir, after completion of whole chapter. Yeah, okay, Emma, you like that. Okay, thank you. Next 11 or revision of 12. Next 11th or revision. Emma, what we're going to do is, first of all, we try to complete few chapters of 12th, and then we'll try to move on 11th, guys. Okay. So guys, if you are clearly understanding the class, make sure that you like the video, share with your friends, tell your friends to join the class on time from Monday on. Please make your friends comfortable to join the class. Okay, ask them to join the class because I'm trying my hard to make you understand lots of efforts. Okay. Okay, just a minute. What happened? Okay, guys. So that's all for today. Thank you so much for joining class. Thank you. Thank you so much, guys. Bye bye. And please make yourself comfortable and interact, guys. YouTube live students, please try to interact. Bye bye. Bye. Bye, guys. Thank you. So, have everyone have filled their NPS? Yeah, most of you have filled that. That's very good. That's really nice. Okay, guys. Thank you. That's all for today. We'll meet there in next lesson. This